To find the area or probability of a normal curve, we have to use the z-score formula x minus mu over sigma. So IQ scores for adults are normally distributed with a mean of 100 and a standard deviation of 15. Using this information, we're going to find the probability that you will select a random IQ score that's less than 120. So first thing we need to do is we need to find our mean and our standard deviation, our mu and sigma. So mu is going to be 100, because that's what it says in the question. And sigma, our standard deviation, is going to be 15, because again, that's what it says. Now, you want to randomly select an IQ score that's less than 120. So that means our x value, our particular value, is going to be less than 120. That's what we want. Once we have all our information, we're going to plug it into our z-score formula. So z equals 120 minus 100 over 15. And when we run that through, we're going to end up getting 1.33 repeating, but a z-score typically is rounded to 2 decimals. Now we got to find the probability. Now the less than part is where it comes in. We want less than 120, so that means we want to find the area less than 1.33. So we're going to use our normal CDF option in our calculator. So we're going to do normal CDF, and we need our lower bound. So since it's going down, it's less than 120 or less than 1.33, we're going to pick an arbitrarily large negative number. So we're going to say negative 9999. That will be our lower, and our upper is going to be our z-score, 1.33, because that's as high as we should go for this particular question. Once we have everything set up, we're just going to bring up our calculator, and we're going to let it do the work for us. So second vars, number 2, we're going to have negative 9999, comma 1.33 as our lower and our upper. And then we just hit enter, and we're going to get 0.9082. So the probability of getting an IQ score less than 120, 0.9082. Now let's do it again, except we want a randomly selected IQ score to be greater than 97. So our mu does not change, still going to be 100. Our standard deviation is not going to change, it's still 15. But our x value is going to change because we want it to be greater than 97. So once we do that, we plug it into our z-score formula. So 97 minus 100 divided by 15, and that's going to give us negative 0.2. So in normal CDF again, we're going to pick our lower and our upper. Our lower in this case is going to be negative 0.2 because we want it to be greater than, so it's going to the right forever. So our lower is negative 0.2, and since it's going to the right forever, we're just going to pick a large positive number, so 9999. Setup is all done, so now we go to second vars, and we're going to plug in our lower bound, so negative 0.2, and our upper bound, 9999. I did an extra 9, but that's okay. And here we're going to get 0.5793. So 0.5793. That's the probability of getting an IQ score greater than 97. Now what if we want an IQ score that's between 90 and 115? No problem, very simple. Our setup again is the same. 100 for our mean, 15 for our standard deviation, but x this time is going to be between two numbers, between 90 and 115. So that means we're going to find the z-score twice. So give myself a little bit more room, and we're going to do z equals 90 minus 100 over 15, which is going to give us negative 0.67 And then we're going to do z again. Z equals 115 minus 100 over 15. And that means we're going to get a z-score of 1. So we're going to find the normal CDF between these two values. So normal CDF, our lower being negative 0.67 and our upper being 1. Once we get that, just going to bring up our calculator and let it do the work for us. So second vars, normal CDF, lower is negative 0.67 and our upper is just 1. Close, hit enter, and we get 0.5899. So equals 0.5899 as our answer. So whether you're doing something that is between two values like we just did, or you're doing something that's greater than or less than, it's all the same. Normal CDF can do it all for you. So just be careful, make sure you put the numbers in order from smallest to largest, otherwise you could end up with sign errors.